Okay, welcome to question number 2 for the mass-to-mass stoichiometry problems. This question says, how many grams of solid magnesium oxide is needed to react with 10 grams of liquid water to form solid magnesium hydroxide? All right, so remember step 0 is to check the equation, make sure it's balanced, and in this case it is. I did my tally. So all the coefficients here are 1. They're an invisible 1 in there. All right. Now I can go ahead and identify my given and find. I have, so it says how many grams of solid magnesium oxide, so how many grams of it. I'm looking for grams of magnesium oxide. So my find is question mark grams magnesium oxide, and I'm given 10 grams of water. Okay, so my plan is I'm going to start with my 10 grams of water, that's my given. I'm going to find my moles of water. Once I have the moles of water, I can find the moles of my fine magnesium oxide. And once I have my moles of magnesium oxide, I can get my mass of magnesium oxide. All right, so let's do my work here. So again, step 1. Going from grams of water to moles of water, I'm going to use the mole equals mass over molar mass. So I have I'm looking for the moles. I have the mass as 10 grams. I need to get the molar mass of water. And for that, let me zoom in a bit here. We would use the periodic table, okay? So look on the periodic table, and the molar mass of water, when you add it all up, is 18.02 grams per mole. So I can divide these two numbers out, and that'll get me my moles of water. Just give me a second here. Okay. So I'm going to have moles of H2O to be 0.555 moles. So 0.555 moles. All right. All right. Now I'm here. So my next step is to convert from moles of water to moles of magnesium oxide. That's where I'm going to use the coefficients in the balanced chemical equation. Remember, these are all 1s. They're invisible 1s in here. All right. So this again makes my math easy when they're 1 to 1. So what I'm taking is the 0.555 moles of H2O. Notice I'm putting the number, the measurement, the unit of measure, and then also the substance. It's important for stoichiometry to do that because you're converting from one substance to another and you want to make sure you got it all right. Okay, so once I have that, what I need now is the conversion factor, which comes from the balanced chemical equation. I'm converting from moles of water. So this part of the balanced chemical equation, that coefficient and the substance, that comes down as my 1 mole of water. And then what I'm trying to find is magnesium oxide. So the part of the equation that has it, which is this part, goes there, right? Remember, they have to be opposite to cancel. I want to cancel out the waters. All right, the math is easy once again. So that's 0.55 times 1, essentially. So that means that 0.55 moles of water needs 1 mole of magnesium oxide. Okay, so that's my answer there for step 2. All right, now I need to go on to step 3. So I'm going to put a dividing line here. Get my work kind of divided out. There's a lot of work here when you do it step by step like this, instead of with dimensional analysis, but I think it's more conceptual. Okay, so let's do step 3. Step 3 is to calculate the mass of the magnesium oxide, because I don't want the moles of it, I want the mass. So we're going to use the mole equals mass over molar mass equation. Now I have the moles of magnesium oxide, so I plug that in for that portion of the equation. I'm looking for the mass. Once again, to solve this, I need the molar mass. So I would go to my periodic table and find the molar mass of magnesium oxide, just calculate that. And when you do that calculations, you get the molar mass of magnesium oxide to be 40.30 grams per mole. So then that number goes here. Now to solve it, I just multiply these two out, and then that's when I get the mass of magnesium oxide to be 22.2 grams. And that's the final answer right here. So just to quickly recap, this question was asking me asking us how many grams of magnesium oxide, so how much of this is needed to react with 10 grams of water. So once again, I go through the process, convert the grams of water to moles of water. And then the next step is to convert the moles of water to moles of magnesium oxide, and then moles of magnesium oxide to grams of magnesium oxide. And through that process, I found that for the 10 grams of water, you need 22.2 grams of magnesium oxide. All right. Now, once again, if you're looking at the ratios, you think, oh, it's 1 to 1, so 10 grams of this should give you 10 grams of that. That's not true. Remember, they are not the same substances. They have different molar masses. So 10 grams of water is not going to have the same number of moles as 10 grams of magnesium oxide. So we have to go through this entire process. All right. You have some problems to try on your own. I hope you found this video helpful. Have a quality day.